They glide across oceans like shadows, silent, fast, and packed with enough firepower to change the course of a battle. But how does a modern destroyer go from raw steel to a high-tech, war-ready machine? In this video, we'll take you deep inside the shipyards, assembly lines, and sea trials that turn blueprints into one of the most powerful surface vessels in the world. From engine rooms to missile launchers, and from sonar arrays to flight decks, this is not just shipbuilding, it's a masterclass in naval engineering. So grab your hard hat. We're about to build a destroyer. Shipyard and raw materials. Every destroyer starts not with a bang, but with tons of raw steel. At a sprawling coastal shipyard, the transformation begins. This isn't your average construction site. These shipyards are purpose-built to handle thousands of tons of naval-grade steel rolled into massive plates, each precisely cut with laser-guided machines. Why naval steel? It has to be strong enough to take a hit and flexible enough to ride out stormy seas. Before any construction begins, engineers choose steel that can handle saltwater corrosion, high pressure, and battle stress. Then, massive steel plates are shipped in, stacked like giant playing cards, and carefully stored under controlled conditions. Every piece is planned to the millimeter. CAD, computer-aided design, models guide laser cutters that shape the plates into puzzle pieces. These parts are the future skin and skeleton of the ship. But raw steel alone isn't enough. The pieces are treated with anti-rust coatings and reinforced with ribbing. Special attention is given to weld points, the invisible glue holding it all together. Here's where human skill meets robotic precision. Certified welders, often working alongside robotic arms, create seams so strong they're rated for high-impact warfare. This is the part of the process that feels like laying the DNA of the destroyer. Everything from the armor rating to the future stealth features starts with how these first steel parts are shaped and joined. The ship hasn't taken form yet, but its soul is being forged. Keel lay and modular block assembly. Once all the parts are ready, the real build begins with the keel. This is the ship's spine, and laying it down is such a big deal that the Navy often holds a ceremonial event. It marks the destroyer's official birth. Modern destroyers are built using a method called modular construction. Instead of building the ship piece by piece from one end to the other, huge sections, called blocks, are built separately. You'll have blocks for the bow, midship, stern, and even the bridge. These blocks can weigh hundreds of tons and are built in parallel, which saves time and lets teams focus on their specific sections. Each block is outfitted with key components before they're even put together. Floors, bulkheads, and even some internal wiring are installed while the section is still on land. It's like building a Lego set, but each piece is the size of a house. With the help of automated cranes and cam-guided tools, the blocks are moved and welded together. Precision is everything. Even a tiny misalignment could mess with the ship's balance or cause leaks under pressure. Before it ever touches the water, the partially assembled destroyer is tested for leaks and structural stability. Water is pumped into compartments, pressure tests are run, and the hull begins to take shape. At this point, you can walk through the skeleton of the ship and start imagining what it will become. Hull completion and launch process. With the blocks fully joined, it's time to finish the ship's hull. Workers start by adding the outer plating, including the distinctive bow flare and side curves that help cut through rough waters. This is where the destroyer starts to look like a warship. Then comes paint. Not just any paint, but specialized anti-fouling coatings. These help prevent marine growth and reduce drag, keeping the ship fast and efficient. The hull is also primed for stealth, with colors and coatings that help it blend into the ocean's surface on radar. The next big moment is the launch. The ship is now fully shaped and ready to meet the water. Depending on the shipyard, it might be rolled onto skids and slip-launched into the water, or carefully floated off a dry dock. Either way, it's a dramatic moment, the first time the steel beast floats. But the work isn't done. Engineers perform flex tests to see how the hull handles stress in real water conditions. These stress tests simulate the force of waves, turns, and sudden changes in direction. If the hull passes, it's a green light for the next phase. Now the destroyer is in its element, floating, hulking, and finally ready for the machinery and weapons that make it a true force. At sea, superstructure and bridge construction. After the hull is afloat, attention turns skyward. The superstructure, that tall, angular tower rising from the deck, is assembled piece by piece. This isn't just for show. It houses radars, antennas, communication systems, and most importantly, the bridge, where the ship is controlled. Every surface is designed with stealth in mind. Flat angles and special materials help reduce radar signature, making the destroyer harder to detect. The bridge itself is a two-story command center with 360-degree visibility and armored glass. From here, officers steer the ship, manage communications, and monitor combat systems. Inside, a complex web of fiber optic cables and backup systems runs like veins. These ensure that even if one part fails, the rest of the ship can keep operating. Redundancy isn't just a luxury, it's a survival tool. The Combat Information Center, CIC, often located just beneath the bridge, is installed next. This room is the ship's brain during battle. From here, radar feeds, sonar contacts, and weapon systems are monitored and controlled. The superstructure is where the destroyer comes alive. Not just a ship, but a high-tech sentinel capable of tracking and fighting threats across sea, air, and even underwater. Power and propulsion. Now comes the heartbeat. Engines and propulsion. The destroyer is powered by 4 gas turbines, similar to jet engines, but designed to turn huge shafts connected to the ship's propellers. Each turbine produces 25,000 horsepower, and when combined, they can push the ship over 30 knots. These turbines are installed deep in the hull, alongside diesel generators that provide backup electricity for the entire ship. Every cable, duct, and exhaust pipe is carefully routed to manage heat and minimize the ship's infrared signature, essential for avoiding detection by thermal sensors. Precision is key during installation. The turbines must be aligned within fractions of an inch to avoid vibrations that could damage the ship or make it easier to detect. Engineers test the alignment by running them at full speed, then analyzing stress points and noise levels. Propellers are also installed now. These aren't your average boat screws. They're massive, precisely shaped to cut through water with minimal noise. That stealth is important in modern naval warfare, especially when submarines are listening. This part of the process is loud, hot, and complex. But once finished, the destroyer has something very few ships ever match: raw power on demand and the engineering finesse to stay whisper quiet when it matters most. Mk-45 gun system. With the hull solid and engines humming, it's time to arm the destroyer, starting with its most iconic weapon, the Mark 45 naval gun. This isn't your grandfather's cannon. It's a fully automated, high-speed, long-range weapon that delivers precision firepower from the front of the ship. Mounted right on the bow, the Mark 45 can fire 127mm shells at targets more than 24 kilometers away. But what really sets it apart is the engineering behind the scenes. Below deck, a system of automated shuttles and hoists transports shells from the magazine to the gun in seconds. Every round moves through a choreography of machines, lifted, rotated, loaded, and fired with military precision. Each firing cycle lasts just a few seconds. Shells and propellant are pushed into the barrel, fired, and the empty case is ejected out the side. This system can spit out 10 to 16 rounds per minute, creating a constant barrage that's ideal for land bombardment or anti-ship engagements. To keep things running safely, the crew conducts daily safety checks and misfire drills. These aren't optional. In the chaos of combat, a single jammed round can make the difference between survival and disaster. That's why the gun system is tied into the ship's main targeting network, allowing operators to engage targets using coordinates fed from radar or GPS. Installing and testing the Mk-45 is a key milestone. It marks the moment when the destroyer becomes more than a machine. It becomes a weapon, capable of defending itself and striking targets from a great distance with deadly accuracy. Mk-41 VLS cells. Now we move from cannon fire to missiles, an entirely different league of firepower. Near the center deck, large hatches are cut open to install the destroyer's Mark 41 vertical launch system, often called the VLS. These square, flat-top cells look simple from above, but beneath the surface lies a highly sophisticated weapons grid. The VLS is where the destroyer carries its real muscle. Inside these 25-foot vertical tubes, up to 90 missiles can be loaded, ready to fire in seconds. Each tube is independently controlled, meaning multiple types of missiles can be stored and launched without moving parts or manual reloading. When a launch is triggered, the cell opens, and a blast of fire erupts upward. A hot gas vent channels the rocket exhaust away from the ship, ensuring the deck doesn't melt under the heat. From there, the missile takes flight, guided by onboard computers and external radar feeds. One of the most commonly loaded weapons is the SM-2 missile, designed for air defense. It has a two-stage design. A booster lifts it out of the cell, then a second rocket kicks in to propel it to speeds of Mach 3.5, over 2,600 miles per hour. What makes the VLS so important isn't just the firepower, but the flexibility. Missiles can be swapped out based on mission needs. You could be hunting enemy ships one day and shooting down aircraft the next. Once this system is installed and tested, the destroyer steps into the league of multi-role combat ships, ready for nearly any threat the ocean throws at it. CIWS and RAM. As powerful as missiles are, not every threat comes from miles away. Some come fast and low, like drones, missiles, or small boats. That's where close-in weapon systems, or CIWS, come into play. Think of these as the destroyer's reflexes, designed to shoot down anything that gets too close, too fast. One of the most iconic of these systems is the Phalanx, a radar-guided Gatling gun mounted near the top deck. It's hard to miss. It looks like R2-D2 with a machine gun. When activated, its radar scans for incoming threats. If it sees a drone or missile approaching, it locks on and unleashes a storm of 20mm rounds at 4,500 per minute. The sound alone is enough to shake your bones. Testing the Phalanx is a dramatic moment. In live-fire drills, it tracks and destroys dummy drones launched from a safe distance. The entire system works autonomously, meaning it reacts faster than a human could, reducing the window between detection and destruction to mere seconds. But that's just one layer. Many destroyers also come equipped with the RAM, Rolling Airframe Missile System, another close-range weapon that can engage targets with pinpoint accuracy. It uses a bank of mini-missiles designed to home in on heat signatures and take out threats that slip past the first line of defense. Together, the Phalanx and RAM create a deadly umbrella around the destroyer. These systems are the last word in a layered defense strategy, small, fast, and unforgiving to anything that dares get too close. Anti-ship and anti-submarine systems. Threats don't just come from the sky. Beneath the waves, there are dangers just as lethal, and the destroyer is built to face them all. Along its side, angled missile rails are installed to launch the legendary Harpoon missile, an anti-ship cruise missile that's been in service since the 1970s, but is constantly updated for modern warfare. The Harpoon is fast, stealthy, and devastating. Once launched, it flies low, just a few meters above the sea, to avoid radar detection. It can cover miles of open ocean, guided by a built-in radar seeker and preset waypoints. When it hits, its 227-kilogram warhead can rip through a ship's hull like tinfoil. But while the Harpoon looks out, the destroyer must also look down. That's where the Mark 32 torpedo tubes come in. These launch short-range torpedoes designed to hunt submarines. Once fired, the torpedo uses active sonar to find its target, then homes in silently for a kill shot. Complementing this system is the destroyer's built-in sonar suite mounted in the bow. These sensors emit underwater pings that bounce off hidden submarines, revealing their position. Passive sensors also listen quietly for engine noise or movement, perfect for tracking stealthy opponents without giving away your own location. This dual-layer defense, Harpoon for ships, torpedoes, and sonar for subs, makes the destroyer a predator above and below the waves. In modern naval combat, versatility is survival, and here the destroyer doesn't just survive, it dominates. Sonar, sensors, and electronic warfare. A modern destroyer doesn't just see with eyes or hear with ears. It uses a web of high-tech sensors to feel everything around it. This part of the ship isn't about brute force, but about awareness, tracking, and digital warfare. It starts with sonar. Mounted under the bow is an active sonar dome, which sends out pings into the deep, listening for echoes that bounce off submarine ones. The data it returns is stunningly accurate, allowing the crew to pinpoint objects even miles away. But active sonar is loud, so when stealth is needed, the destroyer switches to passive sonar, listening quietly for propeller noise or metal-on-metal sounds. Above the surface, radar systems take over. The Ku-band radar on top of the ship scans the skies for aircraft and missiles, while tracking systems refine those signals and pass them to weapon controllers. These radars are the ship's first alert system, constantly scanning, filtering, and identifying friend from foe. Then there's electronic warfare, the invisible battle. The destroyer is fitted with ESM, electronic support measures, and ECM, electronic countermeasures gear. These systems detect enemy radar or signals, then jam or confuse them. Chaff launchers release clouds of reflective particles, while flares can distract heat-seeking missiles. Finally, all of this feeds into the Combat Information Center, where data is compiled, mapped, and acted upon. Here, the ship becomes something more than metal and weapons. It becomes aware, making split-second decisions based on a constant flood of information. This is the heart of modern naval warfare, not just firepower, but superiority through intelligence. And for the destroyer, it's what makes the difference between being hunted and being the hunter. Seahawk Helo Deck and Facilities. As we near the back of the destroyer, we find something unexpected: an aircraft hangar and flight deck. Yes, even though it's smaller than a cruiser or aircraft carrier, a destroyer carries its own Seahawk helicopter, giving it air power and surveillance far beyond what the ship itself can see. The Seahawk is no ordinary chopper. It's a naval variant of the Black Hawk, redesigned for sea operations. From the flight deck, the Seahawk can launch with Hellfire missiles, torpedoes, or sonar buoys, depending on the mission. It becomes the destroyer's eyes in the sky, or in this case, over and beneath the ocean. Building the helo deck is more than just adding a flat surface. The flight area must be reinforced to handle the intense rotor wash and landing impact, especially during rough seas. Underneath, the hangar is equipped with fuel tanks, weapons lockers, and maintenance bays, a complete air service station packed into the ship's rear. Every part of this section is designed for efficiency. Navigation lights, safety nets, hydraulic lifts, and even deck markings are standardized so pilots and crew can operate safely in low visibility or combat situations. The communication system links the aircraft to the ship's main computer network, allowing live feeds of surveillance data to appear on screens inside the command center. Operating the Seahawk requires tight coordination. Crew members go through air handling drills, practicing rapid deployment, fueling, and emergency recovery. These drills often use a simulated crash or fire to train everyone on what to do in the worst-case scenario. The addition of an aircraft turns the destroyer into more than just a ship. It becomes a floating forward base, capable of extending its reach by hundreds of miles. Whether it's tracking submarines from the air or striking coastal targets, the Seahawk gives the destroyer a level of flexibility and strike range that few warships in its class can match. Crew spaces and life on board. Beyond all its weapons and tech, a destroyer is also a floating home for over 300 sailors. Life here is tight and disciplined. Sailors sleep in triple bunks with lockers and curtains for privacy. Space is tight, so every inch counts. Stairwells double as escape routes, and safety gear is everywhere. Meals are served in a shared mess hall, and the galley runs like a well-oiled machine, feeding the crew day and night. Supplies are stored for weeks, and resupply missions happen via helicopter or at sea. There's a small gym, reading nook, and digital lounge to unwind, and a basic medical bay with triage, surgery, and quarantine capabilities. Everyone trains regularly for emergencies, fire, floods, or even nuclear threats. Despite the cramped quarters, there's a strong sense of unity. Months at sea forge deep bonds among the crew, creating a family bound not by blood, but by shared purpose. This isn't just a bomb, it's a way of life. Sea trials, certification, and commissioning. Once built, the destroyer enters sea trials, a full-speed test of its strength and systems. It's pushed to max speed, turns sharply, and drills for man-overboard rescues. Every movement is logged, every vibration measured. Then comes weapons testing. Guns, missiles, and torpedoes are fired at sea. These drills test accuracy and how fast the ship can react. Just as vital are the defense drills, damage control, radar jamming, and electronic warfare simulations. Once all systems pass, the ship earns final approval. At the commissioning ceremony, the American flag is raised and the captain gives the order to activate the ship. In that moment, this machine becomes part of the fleet. From raw steel to fully armed warship, it's now more than metal. It's a guardian of the seas, brought to life by the sailors who run her. From welded steel to ocean warrior, destroyers are the ultimate blend of power, precision, and purpose. If you enjoyed diving into how these ships are made, don't forget to like, subscribe, and share. Let us know which war machine you'd like us to break down next. See you next time.